continuing on with the final. Here we're asked to simplify expressions, sometimes by performing division or addition beforehand. It's going to include some factoring and then reducing. If I look at number 19, where it just tells me to simplify the expression, my goal here is to factor the top, factor the bottom, and then cancel out anything that's a repeated factor on top and bottom. So on top, I have a trinomial, a equals 1. I create my two parentheses, x and x. This negative tells me the first sign's negative. This positive says same sign, so also negative over here. I'm looking for two things that multiply to 3 and add to 4. Well, the only way to multiply to 3 is 1 times 3. Luckily, they do add to 4. So I put the larger one here, the smaller one here. Same idea for the bottom. I set up my two parentheses, x and x. I bring down the first sign, positive. This tells me different from the first sign, different from positive, is negative. I'm now looking for things that multiply to 21 and subtract to 4. The ways to multiply to 21 are 121 and 3, 7. 21 minus 1 gives me 20, not 4. 7 minus 3 does give me 4. I put the larger one first, the smaller one second. Now that I see it completely factored, I do see a repeated factor, specifically this x minus 3. Once I cancel it, my final answer becomes x minus 1 over x plus 7. Number 20 asks me to do the same general thing where I'm going to be factoring and canceling. The difference is because of this division symbol, I need to remember that I'm flipping the second fraction as I go to cancel. So I'm going to rewrite the first fraction by factoring the top. X squared minus 9 is the difference of squares. It becomes x plus 3, x minus 3. When I go to do the bottom, 6x plus 18, only thing I can do there is pull out the greatest common factor, which is 6. If I pull out that 6, it leaves behind an x plus 3. To change this division to multiplication, I have to flip what's on top on the bottom. So this used to be division with x minus 3 over x plus 3. Now that I've changed it to multiplication, what was on bottom is now on top, x plus 3. What was on top is now on bottom, x minus 3. At this stage, I can cancel between any of these. So this x minus 3 and this x minus 3 can go. When I have one x plus 3 on bottom, two of them on top, I can only cancel 1 for 1. So it's fine if I cancel this one, it's fine if I cancel this one, but I can't cancel them both. So I'm going to get rid of this one and this one. That leaves me on top with this x plus 3, on bottom with this 6. So my final answer would be x plus 3 divided by 6. For number 21, this is the type of addition that I love, where I already have a common denominator. All I have to do is remember to keep that on bottom and add what's happening on top. So this was over x plus 7, this was over x plus 7. The final answer will also be over x plus 7. Since I'm adding, I'm going to combine like terms. 3x is going to combine with x. 11 is going to combine with 17. 3x plus x gives me 4x. 11 plus 17 gives me 28. It's all over x plus 7. In general, these questions are designed so that something will reduce. You'll notice that on top, I can take a 4 out of both things. That gives me 4 parentheses x plus 7, which does reduce with that x plus 7 on bottom, and just leaves me with a final answer of 4. Number 22 is the type of addition or subtraction that we don't really like. Basically, I cannot combine these in the form that they're currently in, because unlike problem 21, where the two bottoms were the same, these two bottoms are not the same. In order to make them the same, I'm going to need to multiply by the other bottom. So here on the left, where it has x plus 1 on bottom, I'm going to multiply by what's on bottom on right, x plus 3. Here, I've got x plus 1 on bottom. I'm going to multiply top and bottom over here by that x plus 1. So, on bottom, I'm going to leave it as x plus 3 times x plus 1. On top, I'm going to do some multiplication. 3x times x gives me 3x squared. 3x times 3 gives me 9x. X times x gives me x squared. X times 1 gives me x. 4 times x gives me 4x. 4 times 1 gives me 4. Sorting everything out on top and making sure that I'm combining like terms, this 3x squared and this x squared give me a total of 4x squared. This 9x plus this x gives me 10x, plus this 4x gives me 14x. This is the only thing that doesn't have an x, this positive 4, so it goes there. On bottom, I still have x plus 3 times x plus 1. If this was easy to factor on top, I'd say go ahead and factor it. In this case, it is nothing that I really want to mess around with. Neither of these go into factor the top, so I can stop there and leave the equation like that. In general, for 22, this is the one where you don't want to be looking too hard for stuff that's going to cancel out. It's really hard to make those problems fit nicely, but something like 21, 20, 19, all of those should have something that reduces.